All right, so now we had a look last week on how to do histograms. So we've got a couple just drawn up here. So with histograms, remember we had continuous numerical data along the x-axis. And now what we're going to do is, now that we've displayed it like that, we need to describe the data, because that's what we're all about, is like getting the data, presenting it, and then telling, the people, okay, what does this data show you? So if you find that you have your data that looks like this, so sometimes it can look like, we say, a bell shape, or, if you put a line down the middle, it would be like a mirror image. When we say like that, we say it's symmetric, okay? If we have a positive skewed shape, what we see is, we see the big high towers at the start, and then it tails off like that. That's positive skewed. And then if we see more lower towers at the start, and then we get high towers at the end, that's negative skewed. Now, when you see one like floating out here by itself, we would call that an outlier. So this one, just so you might want to describe this one would be negative skewed with an outlier. They may say negatively skewed or negative skewed. It doesn't matter, like, we're not going to pull you up on it as long as you say negative and skewed, okay? So there's our different shapes. So when we're describing, shape is one thing that we talk about. So shape could be symmetric or positive or negative skewed, with or without outliers. The next thing we're going to describe when we're looking at our data is the center. And the center we generally refer to the median or the mean. But let's put a little comment. This one, the median, is probably better. And we're probably better because it is a resistant statistic. So what a resistant statistic means, it's not affected by outliers. So the middle of your data will still be, the median will still be the median. It doesn't get dragged up or down like the mean will, so the average. So if you want to just write under here the mean, so maybe the sin is affected by outliers. So we only really use the mean, so only use in symmetric data. So, and because I'm saying only using symmetric data, but the median can be used in anything, so you're sort of better off always using, if you're not asked to quote the mean, just use the median. That's the best one because it can work. It's good for all types of data. Okay, so what we're going to look at, so if we're going to just have a look at our explanations of that, so what you'll find is the median is, so remember, if we have the median's when you put your data from lowest to highest, okay? So you would line them all up in order from lowest to highest, and then you see your median is in the middle of it, yeah? So your median, so you have 50% of data above it and 50% of data below it. So what you'll find is that the median always is sort of in between, in the middle of the big chunks. So say here. So if you have, and I'm just going to draw some examples because they didn't really have it. If we have, say, a positive skewed, histogram like this, okay? What you're going to find is the median value will be somewhere around in here because that's where all our data is. You've got a lot of data, so a lot of data comes before it and then it drives off. What you'll see where your mean is, because your mean, you add them all up and then divide by how many. These little high numbers, they drag the mean up. So it doesn't really look like the center of the data, okay? So the mean gets dragged up. And if you have the other way, so if you had the other way where we have small amount of data and then we get larger like this. So what we're going to find is those low numbers cause the mean or the average to be lower, but we'll see the median will still be, the median would be up here. So you can see when we might write a note there. So when we have positive skewed, the median is lower than mean. And then when you have negative, just going to abbreviate skewed there, negative, sorry. When we have negative skewed, the median is higher. So sometimes if you're a little bit unsure of the shape of a histogram, you could have a look at the mean and median on your stats and go, oh, well, the median is much higher, so I'm going to say that that's negative skewed. All right, so just to explain it a little bit better. So say we had our class here and we put you all, and I recorded all your weights, okay? So I recorded all your weights of this class and you're all around the same. So we put you in from lowest to highest and we're going to say prop you in at, so say 70 kilos is your median. So the middle person is at 70 kilos. If we average you out, you're probably going to be all around because let's say roughly. Okay, now what happens if I bring in just one extra student and he has got the world record for being the largest 17-year-old in the country. So he comes in. If I worked out your average, he's gonna be a big chunk of adding on. So what happens is your average gets dragged up. But if I lined you all up in order, the middle person will still be roughly the same as what it was before. Okay, so that's how we're saying that the median is not affected by the big outlier where the mean is. All right, let's keep going. So that was talking about the center. So then the last thing we have to talk about is the spread. Now the spread, can we also write here, sometimes they call this variability. Okay, so it is like how it's sort of, we might say ranging. Okay, so that sort of gives it away. When we want to talk about the spread, we either talk about the range or we could talk about the interquartile range. Now, just like the mean and median, I'm going to tell you that this one, the range though, the range is affected by outliers. Because if you think about it, if you just think about that example I just said before, remember, if I bring that big kid in, my range is going to be really large because he's the highest weight minus the smallest weight. So my range gets like thrown way out. But really, if you think about it, most of you guys are all hanging around the same weight. So that's where the interquartile range, this one is a resistance statistic as well. So resistant statistic. So not affected by outliers because it tells you the middle 50%. So this one, so it tells you the middle 50%. So it's a better version of the rate of telling you because that 50% is the majority. So if I say, oh, well, the middle 50% range between here and here, that's a good stat to use, okay? So as again, if you're not asked to find the range, if you're just commenting on your histogram, go with the interquartile range because it works for all of them, where the range is not good if we have an outlier, okay? So comparing the spread, so here we go. So if you have a look at this one, if we were just going to compare this spread, so if you look at it, this one's 3 and this one is 11. So I'm just going to compare the ranges here because I'm not going to work out the interquartile range. So this one's range would be 11 minus 3, which is, what's that, 8? And then this one's range is 15 minus 1, so it's 14. So what you would say is this one is more variable. So you've got more numbers of spread is more, so more variable, maybe you say larger spread than histogram G, okay? So more variable, larger spread, okay? Because it has a larger range there, okay? So when they ask you to compare, which is what we often have to do, compare two sets of data, make sure you have comparing words. So let's just write a little side note to help us here. So just so that you remember, so when you're writing those reports, or, you know, when you're asked to compare, so comparing words would be, you know, one is larger, yeah, smaller, maybe, you know, more or less. So you really need a comparison word. Do you understand? Or when it says compare, or you may say they are similar, but you're still comparing it, yeah? You're saying or similar or same, but you need to say how there's a difference, okay? So remember that when you ask to compare, we need comparing words. All right, so now what we're going to do is have a quick look at dot plots. So we are going to do this dot plot in our calculator because I'm going to show you. So let's have a look.